Can you please check? Are you able to see the screen now? I think there was some technical error. So the recording earlier that was not this today's discussion not recorded. So I will start the recording. I will quickly go one by one. So if you have any doubt, please let me know. So welcome all of you. So this is our sixth session on the molecular rearrangement and reactive intermediates in the organic synthesis. And here we'll discuss some of the sample problems based on the week 6 topic, and which is basically based on the enzyme intermediates and their reactions. So I will directly move toward the some sample problems. So this is the first problem that we have already seen. I'm discussing this one just for recording purpose. So please don't mind. You can skip this part. And yeah, so this is the first question. The among the which is the correct option regarding the enzyme intermediate. So you have the enzyme intermediate given. So it is obviously based. The question is based on the aromaticity and the so whether it is aromatic or anti-aromatic or non-aromatic, that you need to identify. So if you look at the structure of this enzyme intermediate, which is this lone pair. So I'll just show that this one. Yeah. So in the benzene, this extra bond, so which is part of the which is not part of the aromatic system. So which is not involved in the aromatization. So the only inner three double bonds were involved. So that corresponds to the 6 pi electrons, and the outer two, so which is not part of this, these 2 pi electrons, which is the additional. So these are not involved in the aromatization. So overall, this compound is aromatic. The other stay point in this question is the these bonds are not involved in the aromatization. So that's why this compound is aromatic compound. Otherwise, if you count directly the 8 pi electrons, so it is not like that. So this part are not involved in the conjunction. Therefore, it is we need to only count this 6 pi electron, which is again the 4n plus 2 pi electrons. So n is equal to, you can put whether it is 0, 1, 2, 3, 4 up to n, right? And so it will be the systems which have the whether 2 pi electron or 6 pi electron or 10 pi electrons or 14 pi electrons, they are aromatic systems, and these are the aromatic. So you can refer this one. The next one is the vibrational frequency of the triple bond in the enzyme intermediate. So if you look at the frequency of this carbon-carbon double bond, so you take the any example like the olefin, it is around 1650 centimeter inverse, right? And if you taken this is the triple bond, carbon-carbon triple bond, so which is nearly uh, 2000 2150 centimeter inverse. But what is the frequency of this triple bond of the enzyme? So this enzyme, this frequency is in between double bond and triple bond. So this enzyme intermediate is like in between, the frequency is in between. So I will just neglect the wrong options. So in this case, this is 1544 centimeter inverse. That's the wrong option. This is again wrong. And this is again wrong. So this is the correct option here. So this is in between. between double and triple bond. So here is the statement for that one. So you can refer this. So this vibration frequency of these triple bond in the benzyme was assigned by the Radizewski. It is around 1846 centimeter inverse. So that value you need to keep in mind. Whereas for the double bond, it is around 1600 and 650, and for triple bond, it is 2150 centimeter inverse. The next question regarding the addition elimination type of reaction. So here, so if you look at this, the starting, so this is the strong base. So this base abstract the proton and it forms a benzyme intermediate in between. And then what happens? This again second molecule of the uh, third butoxide, which attacks again on the position, and further it abstracts the proton from the solvent to get the our desired our final product. So which type of intermediate involved in this one? So if you look at this reaction, sorry, this reaction follow the pathway the via elimination addition reaction. So first step is the elimination, and then second step is addition. Here is the detailed solution. You can refer this one. Yeah. So this is the elimination reaction, first one, and the second one is the addition reaction. All right. The next question is based on the similar approach, and I will just show you. So you need to identify in this one which is the eliminating group. So if you look at the structure, so in the structure, so the eliminating group is this entirely group is the eliminating group. So the first step is the um, so here is the one proton and here is the eliminating group. So this proton, the base abstract this proton, then this elimination takes place and it gives the benzyme intermediate. So this is the intermediate it's formed, and once this intermediate form, again the next step is the uh, this is the elimination reaction, and the next step is the furan addition of the furan across this benzyme. So this benzyme, this is the 2 pi electron system, and this is a 4 pi electron system. So the benzyme is 2 pi electron from the benzyme and the 4 pi electrons from this furan. So this is 4 plus 2 pi addition reaction. So this is the part of the peroxide reaction, right? And this furan, so basically it this attacks here. So this bond moves to here, this bond move here, and then further attack at this position. So we get a product. So if you look at these are the wrong option. I will just neglect these wrong options. And among these two, so as I have shown, in this case there was a two different type of protons available. So if you look at here in the structure, so this is the one proton, this is the another proton. So which proton is preferably abstracted? So this is the one proton that I have shown with this one proton. With the other proton, if you do the same reaction with the other proton on this second proton, so we'll get the similar sort of intermediate. So that intermediate will be like this. This is the Cl that, right? And on this proton, again there is the furan can attack and gives the product. So this one is the P1, I just write, and P2. So which one is the correct product here? So if you look at here, In this one, they have not mentioned any the chloro group. So that's obviously the wrong one. So this one is the correct option. So which chloro group is abstracted basically? Sorry, which hydrogen is abstracted in the product? So can anyone tell me? So you have the two options. I will just label that one, whether it is A or B. So you have the A hydrogen and you have the B hydrogen. So this is the route I have shown with this B hydrogen abstracted, right? And the another route, that this one route is with the A hydrogen abstracted. So which hydrogen is AT abstracted to form this product? So basically to form this product, here there need to be a triple bond, right? So this means the triple bond should be addition to the chloro. So here, so obviously to make this product, you need to abstract this B hydrogens. So the B hydrogen is abstracted by the base. And why the B, not A? The reason is we have here the chloro group and which is electron withdrawing group. And that's the reason this B hydrogen is the more, we can say, the electron deficient compared to the A hydrogen, right? So I will take the next question. So in between, you just note down this mechanism. So this is the next question. And if you look at the question, so here given which is the correct statement for the following reaction. So you have given NaNO2 HCl and followed by uh, it gives the product A, and after that there is a, we have given the pi electron system, 4 pi electron, and under thermal condition, right, heating. So what this reaction goes, so if we add the NaNO2 HCl to this compound, which is having NH2 and COH group, what happen in the product? Anyone? You have to speak, otherwise it will be difficult to just check. Right. So what happens? The NaNO2 react with the NH2, it forms a N2. And once this N2 is formed, uh, under the presence of hydroxide, it forms the this oxygen obviously. Uh, this COOH gives the COO negative anion, and this N2 is positive cation. So under thermal, what happens? This entire compound uh, undergo decarbonylation. So the CO2 group is eliminated and this N2 also eliminated. So this CO2 and N2 is released from the starting and you get the benzyme intermediate. And once this benzyme intermediate is formed, so on this benzyme intermediate, so there will be a 4 plus 2 pi addition reaction. So that's the dial solder type of reaction, right? And we get a product. So basically, So whenever you see this such compound, so if you look at the first step, what was the first step? The first step was the NaNO2. So obviously, what does NaNO2 do? So if you have any NH2 group and in place of NaNO2 HCl, it undergo this amine get converted into the N triple bond N. So this compound. And after workup, what happens? So obviously we need to perform second reaction. We need to do workup. So to remove this acidic, we obviously add the base, right? So under workup condition, so this compound, which has this N2 plus and C double bond O negative, on this reaction under heating, what happens? Under heating, this CO2 is eliminated because this in this way, and N2 is also good link group, so N2 is also eliminated, and we get a benzyme intermediate. And this benzyme intermediate undergo 4 plus 2 pi addition, that is diacetyl reaction, and we get a product. So this is the product form, right? And among the option, which option is correct now? So A is benzyme and form via elimination addition reaction. The second one is the A is the benzyme and form via fragmentation. This is obviously a wrong option. A is the free radical. Obviously, this is wrong. And A is the benzyme formed via Zwitter anion. So this again, the Zwitter anion is the, again, you can say this is a kind of correct option, because if you look at the same molecule which has the positive and negative charge, so we can say that one also. So what will be the, whether it is formed by elimination addition reaction or from the trend? So that's we need to check. So anyone have any idea which reaction? This is already covered by professor. So this is formed via Z2, because within the same molecule there is a positive and negative charge, and that's the reason. So the option D is the correct option here. I will take the next question. So the next question I will choose from the now from the as we are seeing the benzyme. So on the benzyme only, some new type of reaction. I will check some example. So if we have the benzyme, so what will be the hybridization of this benzyme? I will share the screen. So what will be the hybridization of the benzyme? So you have the benzyme, right? So this is the benzyme. So what is hybridization of this carbon? Particularly, I will highlight the carbon, which carbon that I am referring. So these carbons, so this is the carbon, and these are the two carbons, right? So what is hybridization for this carbon? Because you know the in the benzene, so these carbons are sp2 hybridized. And I mentioned earlier, so this benzyme, which is aromatic, and these pi electron not involved in the conjugation, but still, so this is aromatic, and I mentioned these pi electrons not involved in the conjugation. So it is now, the question is whether this carbon is sp hybridized or sp2 hybridized. So this carbon is sp hybridized. So these carbons are sp hybridized and other carbon are sp2 hybridized. So that you have to keep remember. So that's like some sort of another question. So the hybridization of this carbon of the benzyme is the sp hybridization. Next similar question that we have already seen, and which is like basically I will take the question. The major product formed in the following reaction. Here is the example of the reaction, and what is the major product formed in the following conversion. So you have given a compound which has the aromatic compound, the benzene ring which has the methoxy group, TMS and OTF group. And in place of cesium fluoride in acetonitrile solid at room temperature, and we have added the thiol. So what are the product? Anyone? So what happens when this cesium fluoride, that's the is again the base, right? Yep, minus the strong base. So it abstract the proton. So which proton it will gonna abstract? It's not it doesn't react abstract the proton. This is a nucleophilic. It react to the TMS. So basically the TMS is like the silyl protection. It attacks on this F minus, attacks on the uh, Si. Then this is the OTF. So this bond goes here, this goes here, and we get the benzyme, right? And once this benzyme is formed, this again react to the SH. Now, at which position this SH gonna attack? So SH, this attacks at this position. This bond go here, and then it abstract the proton from the solvent. So it S is the pH, and that's the O MB group. So this is the product. So if you look at the options they have given, so this option is the correct option here. So does anyone have any doubt up to here? So I will take the next couple of questions based on the same benzyme, and which will be the very similar as the example that we are seeing. All right. So this is the question. Major product formed in the following reaction. So you have added the butyl lithium on the compound which has the iodo group. So basically, it is gonna perform the lithiation reaction. So OMe, and here there is the negative charge will form, and here OTF. So once this OTF, this again forms a enzyme at this position, and now what we have a such compound. So it is basically the protected enolate. I just draw the structure O T, and this O Si, and this R. I just write this R. So, and here there is a double bond, proton, proton. So basically, this is the double bond O, C negatively charged, and this is OTS, sorry, OET. So this is the inlet. So this inlet attacks here, and this bond goes here. This is correct. So I will just reconfirm the reaction mechanism. Okay, but to form the inlet back, we need some sort of driving force, and that is absent here. So the inlet is not further attacks on that one. So it will be go like 2 plus 2 type reaction. So I will just show the mechanism how this one. So this will be 2 plus 2. So basically, once this benzyme is formed, OMe, and we have now, so this alkyne, this HH, so they undergo 2 plus 2 type of cycloaddition reaction, and it gives the this product. And under aqueous condition, what happens? So this OET, this in the HF, sorry, this goes like this, and it forms a ketone. Excuse me. So these are the some examples that I want to show. Remaining examples are so similar. I will just put that one. So you just try to solve that one. Otherwise, I will solve in the next session. So here's the question, another question. So again, here you can directly see TB80, which again for this, I will put the mechanism, but before mechanism, you just try to solve that question. Otherwise, you can refer my presentation slide. So this is the answer for this one, retail mechanism. But it is very similar to the earlier question that we have seen already. And again, there are some similar questions. So this is the question. So major product form in the following reaction. So you have given the cesium fluoride and the TMS. Again, you know how the benzyme intermediate formation takes place via, benzyme intermediate formation followed by attack of NH and the. So this is interesting question. I will just show. So what happens? So this is the cesium fluoride. So this react with the TMS as we seen earlier, and it forms the benzyme, right? So this F minus attack on the silicon, excuse me, and it forms a benzyme. And once this benzyme is formed, now we have the amine. right? Which is although tertiary amine, but still we know the tertiary amine they are still have the nitrogen still have the lone pair electron and it is available to attack. So this is, let's say, the lone pair which attacks here. And what happens? So I will just show the step by step. This is the N now, right? Now this is the entire, and I will just so this is the, sorry, double bond to remain as it is. This N and this one was part of the cyclic ring. And what's this one? This is the negatively charged, right? So this negative charge form here with this attack here, this goes here, negative charge form, and this negative charge attacks on this carbon. Further, this double bond move to this one, and then the positive charge form here, which gets neutralized, right? And we get a product. So which is the product here? So you can see this is the product. The option A is the correct option here. Have you understand this? How I have approached this question? So basically, this is again formation of zwitter ion intermediate and further reaction goes to completion by zwitter ion complex. So this is the detailed mechanism. So the next question is predict the reaction pathway for the following reaction. So you have given a reaction. Please, sorry, the predict the product uh, pathway for the following reaction. So you have given this cesium fluoride, and if you look at these compounds, so OTBS, so obviously it is seal protection, and F minus react with this, obviously it will give the attacks on the silicon, right? Just right. So you have this starting. I will just draw the full structure, so it will be easy for you to understand. Always keep in mind the fluorine has the F negative, has the affinity towards the silicon. So here there was a sorry. So this is the two R groups, and here we have the O, and this is the OR. One, two, three, right? And there is a silicon Si, and there are obviously other groups. So the F minus attacks on the silicon, this F negative, and as a result, so this bond move here, then this bond goes here. So I will draw the pushing arrows with some different colors, so it will be easy for you to understand. All right. So this bond moves here, this bond goes here, and this OTF get eliminated. So now the benzyme is formed. And where the benzyme is going to form? So this here. So this is the benzyme. Now this is the other bond should be remain same. This is the R3. the R2 is same, and here there was a keto is formed, and this is the O, not keto, it's ester. OR. Predict the reaction pathway for the following reaction. Via elimination addition reaction is the answer for this one. Correct? No. This is fragmentation, not elimination, because there is no any group eliminating, right? The initial was like the abstraction of the, we have seen such elimination. So once if the proton is abstracted, then the bond moves here, and this type of, we call it as a uh, elimination addition reaction. But in this case, this is the fragmentation reaction. And this fragmentation is called as group fragmentation. So you can refer the mechanism here. I will just put it the mechanism. Yeah, this is the mechanism. The next question for you is based on the reaction which we have seen earlier. Let's say now you have such strong base NaNO2, NaNH2, and we have these compounds. So there obviously the proton. So this proton is abstracted by the base, right? So the base abstract this proton, goes here, bromine get eliminated. And still you have here, sorry, uh, now there is N which has this with and this hydrogen. So now the lone pair of nitrogen, as I have shown earlier, they can attack. So this attack here goes here, and which is named abstract the proton from the nitrogen only. So it gives the compound in this way. This is the nitrogen and the earlier methyl that remains same. Nitrogen goes here, right? So this is the mechanism of the reaction. So what are the reactive intermediate involved in the following reaction? So what you will say for this one, which is the reactive intermediate? Obviously, it is a arine intermediate, or we call it as a benzyme intermediate, right? This was some of the question that I just want to show regarding this benzyme intermediate. The next topic is I will put some of the questions for you. So try to solve that question, which is basically based on the some Grignard type of reactions. So let's say we have the Grignard. So this is phenyl magnesium bromide. So this is the one negative, EMG, BR positive. Right. So this is the nucleophilic. And if you see the structure, this is alpha beta unsaturated ketone. And what happens if this phenyl magnesium bromide attacks on the alpha unsaturated ketone? Whether it attacks directly on this position. So this is the A I will write A type of attack, and the second type of attack is the on the this position. So this is the B type of attack. So what we call it as a 1-2 addition or 1-4 addition. So if if we have such systems, And we have the nucleophile. So there are two pathways nucleophile follow in such systems. Depends upon the what type of nucleophile it is. So either on this one or either on this one. So we call it as a 1, 2, and this is called 1, 4 nucleophilic addition. So tell me, what is the correct option here? Anyone? What is this methyl magnesium bromide? Sorry, the phenyl magnesium bromide. It is a strong nucleophile. So if you have heard probably strong and weak interaction addition. Right. So this is the strong nucleophile. So obviously it is attacks on the strong, or it in different term we called it as a hard or soft. So we have seen that in case of the bases, there are hard bases or soft bases. Similarly, hard nucleophile or soft nucleophile. So this is hard nucleophile or strong nucleophile, and therefore it shows the 1-2 addition, right? So 1-2 addition means addition at this carbon is more preferred. So this phenyl magnesium bromide attacks by the A pathway. So the attack takes place in this manner here. So the correct answer among this one is the A. The A option is correct option. If you want to refer the detailed mechanism, I will add the detailed reaction mechanism here in the next slide. So you can refer that one. So this is the detailed reaction mechanism. And if someone want the another addition, 1-4, why 1-4 addition not takes place on this one? Sorry, if someone want the addition product, that is 1-4. If someone want from this molecule, if someone want, let's say, this is the phenyl. So, what will be the reaction condition at that point? So, at that time, if you want this compound, then pH MgBr, and you need to add copper, copper salt. If you add the copper salt, then the reaction goes to the this position, 1 for addition. So you find out why, what is this mechanism reason behind 1 for addition with the addition of the copper. So basically, I will tell you directly. So this phenyl magnesium bromide. So as we have seen earlier, we better take the next slide. This pH Mg when it react with the copper salt, whether it is copper iodide or in copper compound complex, so it forms pH Cu pH. So basically, Cu 2 plus and plus 2 phenyl negative, they forms a salt, and that salt now available for the attack, and which is a soft nucleophile, and therefore the addition of this soft nucleophile takes place on the by in the fashion of 1-4. So therefore this Cu2 pH, sorry, Cu pH twice, not Cu2, CuPH twice. That is the negative. This phenyl negative attacks here. It is on the copper. It goes here. It forms a methyl. Either MgBr or copper salt. That's the some other part. But anyway, so by this way, it forms this intermediate and then further abstraction of proton. We get the product. Which product? So this is the product. Now in the same manner, I will take the example on the reactivity of this methyl magnesium bromide or the phenyl magnesium bromide. So here is the one problem. And these problems are based on the week 7 videos. So initial videos you refer. So you have this CS3 MgBr, this CS3 negative, whether it attacks on this position or it attacks on this position. So depends upon the which group is more reactive. Right. So in this way, so this is the reactivity order that I will just give it for you. It easy for you to understand. So this is the keto and here is the ester. So once one equivalent of the methyl magnesium bromide attacks on the keto, um, when we have the one equivalent of methyl magnesium bromide. So in this case, what happens? So this is the double bond O E T and one equivalent one in attack. So this is the earlier ethyl and this is the new methyl and this is now OMgBr. So this negative charge, if you look at this one, so this is the again nucleophilic and this can attack here and O ethyl can eliminate it. It can undergo a cyclization and it can leads to the formation of such product. So this is the ethyl and this is the methyl. So answer D is the correct answer here. Any doubt in this question? So please note these questions. So I will wait for you if you have any doubt, and then I will stop the session today's. Will I put you some more questions? So here, I will take one more example on the. So this is the question. So what happens in this question? I'll briefly explain. So now you have the butyl lithium in the reaction, and this is again the one compound. And here, if you look at here, there are two protons again at this position. So basically, butyl lithium has the one proton, and here you get this negatively charged. That is the reversal of polarity. If you have heard this word, so once this negative charge is formed at this position, it attacks on these bromo, whether it this position, and Mhm. Basically you get this proton, and this O as it is, right? Oh, sorry. Yeah. So this as it is, and then in terms of HgCl2, so this entire group get eliminated and it forms the aldehyde. So it is basically deprotection. So how many carbons were there? One, two, one and two. So this is the one and the two carbons. So right. So this is the one. Option A is the correct option here. So option in the second option, one, two, three, they have written three carbons. But if you look at the starting, there are only two carbons. So this is the wrong. The option A is the correct option here. All right. Any doubt up to here? So if you don't have any doubt, you can leave the meeting and we'll stop here for today.